really hurts na di ko alam ang geometry. Oops, not anymore. Hey there, StudyBuds! StudyBud Fraulyn is back with more lessons about geometry. Just hang in there, StudyBuds, for we are about to learn about angles. By the end of this video, we will be able to learn about angles, how to measure angles, and what are the postulates and theorems involved. Let's get to it. Angles. Do you still remember them in our last video? If you haven't watched it, then please check our channel. An angle is the union of two non-collinear rays with a common endpoint called the vertex. The rays are the sides of the angles. How do we measure angles? The size of an angle is usually measured in degrees. Think of a circle which is divided into 360 equal sectors. Each sector has a small angle at the center of the circle. The size of such angle is 1 degree. In other words, the size of an angle is a measure of how wide the angle is at the vertex bound by the two sides. We can measure angles using an instrument known as a protractor. Based on the measure of the angles, we have names for those. For those angles that are less than 90 degrees, they are called acute angles. 90 degrees angles are called right angles. Please take note that we have a fixed symbol for right angles, and it looks like this. You see this in some diagrams, we can safely say that it is a right angle. Angles that are more than 90 degrees are called obtuse angles. And angles that measures 180 degrees are called straight angles. We have labeled some of these angles. Now, let us explore some theorems and postulates regarding angles. First, we have the angle measurement postulate. It states that for every angle, there corresponds a real number between 0 and 180. We know that angles are measured through degrees, but it also corresponds to a real number between 0 and 180. For example, we have angle ABC that measures 30 degrees, but the measure of angle ABC is 30. See the difference? If we put small letter m before the name of the angle, we don't need to write degrees. Next postulate, angle construction postulate. Let be a ray PR on the edge of the half-plane H. For every r between 0 and 180, there is exactly one ray PQ with Q in H such that measure of angle RPQ is equals to R. For example, we have this diagram here. Imagine that the half-plane H is a semicircle. Points R, P, S, and Q are on the plane. We can obviously see that angle RPS is an angle. Ray PR is on the edge of the half-plane. It constructs an angle RPS and at the same time angle RPQ. Next, the angle addition postulates. If D is in the interior of angle BAC, then angle BAC is equal to angle BAD plus angle DAC. By applying the subtraction property of equality to the equation in this postulate, we can get that angle DAC will be equal to angle BAC minus angle BAD. For example, we have angle DAC that measures 35 degrees and angle BAD that measures 20 degrees. To find angle BAC, we must add angle BAD and angle DAC. We have 20 plus 35. So, the measure of angle BAC is 55. Two angles form a linear pair if they look like this. If ray AB and ray AD are opposite rays, and ray AC is any other ray, then angle BAC and angle CAD form a linear pair. Please take note that the following definition deals purely with angular measure. It says nothing at all about where the angles are. Another theorem. Every right angle has measure 90. and every angle with measure 90 is a right angle. It also leads to theorem, any two right angles are congruent. If the angles in a linear pair have the same measure, then each of them is called a right angle. This definition leads us to Theorem 4-5, states that if two angles are both congruent and supplementary, then each is a right angle. Please take note, if they are congruent, they have the same measure. For example, let R be the measure of the angle. Since angles in a linear pair have the same measure and a straight line measures 180 degrees, then R plus R is equal to 180. R is 90, therefore every right angle has measure 90. By definition, if ray AB and ray AC form a right angle, then they are called perpendicular rays. And we can write that ray AB is perpendicular to ray AC. If ray AB is perpendicular to ray AC, then the lines AB and line AC are also called perpendicular lines. Two sets are perpendicular if each of them is a line, ray, or segment, they intersect, and the lines containing them are perpendicular. Please take note that the following definitions deal only with the measure of the angles and does not depend on their positions. That's all for today's StudyBuds. If you want to practice what you have learned about angles, then check out Project UPTube's Facebook post. We have prepared an assessment material for you guys. See you again, StudyBuds!